Good morning and welcome to the Angry Astronaut. So, keeping the content flying at you fast and furious. And even though I'm releasing content almost on a daily basis, I actually have a backlog of topics that I'd like to talk about. Yeah, believe it or not, there are more topics than I can possibly cover. One that I've been trying to catch up on lately, however, have been the emerging competitors for SpaceX. The competitors, that is, who want to take SpaceX on their home turf, that is to say, low Earth orbit. Because let's be honest, SpaceX absolutely dominates all the payloads heading to that destination, at least if they're launched from the United States. And really, when it comes down to it, SpaceX launches more rockets not only than any other company, but than any other country. Even China can't keep up with SpaceX. It's absolutely amazing. So Falcon 9 after Falcon 9 delivering payload after payload, either to low Earth orbit or to GTO, geosynchronous transfer orbit. In other words, a relatively low orbit that eventually climbs up to geosynchronous orbit. And when it comes right down to it, with all the positive things that I say about ULA and Vulcan Centaur, it is not in ULA's wheelhouse to try to compete with SpaceX in this market. Instead, Vulcan Centaur seems to be pretty much designed to take cargoes all the way out to geosynchronous orbit and not so much to the area that SpaceX has been dominating so completely. Now, of course, ULA does have a lot of contracts for payloads heading to low Earth orbit, but the only reason they have all of those contracts is because they're doing business with people who absolutely refuse to do business with Elon Musk. Otherwise, they wouldn't have that business at all. And of course, I'm talking about the Kuiper constellation, Amazon, that sort of thing. They're not going to do business with SpaceX unless they absolutely have to, and also probably combined with a bit of separating their fingers from their fingernails. That is how much Jeff does not want to do business with Elon Musk. So yeah, ULA has a lot of business, but they don't want to pursue any more business in low Earth orbit. For the most part, they want to go to the areas that they are very good at, that is to say, delivering large cargoes with a significant amount of volume to geosynchronous orbit. So that being the case, what about low Earth orbit? Is LEO just going to remain in the hands of SpaceX exclusively? We're going to find out in just a moment. Also, a quick reminder, please like, please subscribe, and also please hit those notification bells, and also please check the description for various ways to support my content. Believe it or not, in just over 3.5 months, I am going to be moving to the United Kingdom. I definitely would appreciate any help from my British viewers, my European viewers that want to see me make that move. Really appreciate any support that I can get from you. Although, just to give you a heads up, I'm going to be setting up a special GoFundMe page that's going to have benefits for people who want to support this endeavor. So you don't have to donate now. You can wait until I actually roll all of that out. And once again, thanks so much for the support you've given me after all this time. It is absolutely amazing. I've got the best viewers on YouTube. Okay, let's get back to the two companies that are likely to compete with SpaceX here in the near future in low Earth orbit, and that is Rocket Lab and Relativity Space. And they are in turn coming out with their own rockets designed pretty much exclusively for LEO type payloads. And this is, of course, the Neutron and the Relativity Space Terran R. Now, As you can see from the title of this video, I'm talking about these rockets as if they're competition for Starship, but really all they are is competition for Falcon 9, aren't they? At least as far as their payloads are concerned. Why am I comparing them to Starship? When it comes right down to it, by the time these rockets actually are in service, Starship very probably is going to be in service as well and taking cargoes to low Earth orbit. Very big cargoes, possibly. So how, in the name of God, are these rockets to be expected to compete with Starship? How can Falcon 9 compete with Starship for that matter? Well, let's find out. Look at the difference that a single year makes. These are the Terran R manufacturing facilities just a year ago, and these are those same facilities now. Obviously, Tim Ellis at Relativity Space had a very clear idea of how quickly he wanted to move forward with Terran R development and manufacture, and for a very good reason. Tim Ellis apparently decided some time ago that the Terran 1 was not going to be a worthwhile competitor in today's market, that going head-to-head with companies like Rocket Lab in the small-sat market simply didn't make any sense. And he's probably right. In the United States, this market is becoming increasingly crowded, even though currently the only company that exclusively launches small-sats is Rocket Lab. That market is going to start becoming flooded very, very soon. We have companies like Firefly, companies like ABL, who are building rockets that are going to be launched in the United States that carry triple the payload of a Rocket Lab Electron. That being the case, then, these companies are going to be the emerging competitors in the small sat market. They don't need a whole lot more. As a matter of fact, they may not survive in the US market at all. Why? Well, because there's lots of really good alternatives to small sat rockets in the first place. If you don't care where your rocket is headed, if getting your payload into space is enough, then going on a SpaceX rideshare makes a whole lot more sense. It's a lot less expensive. If it does have to go to a dedicated orbit, then a SpaceX rideshare is a terrible solution. However, there may also be another alternative for these kinds of customers on the Vulcan Centaur, because the advanced Centaur 5 upper stage is apparently capable of dumping off a payload in low Earth orbit and then delivering a secondary payload to geosynchronous orbit. This capability, combined with the large number of small sat launch providers that are going to be flooding the American market soon, make this entire industry a very dangerous place to try to do business. Europe is a little bit safer because there are a wide variety of customers in Europe who are either unable or unwilling to ship their cargoes across the Atlantic. And there are lots of reasons why European companies don't want to do this. I'm not going to get into that right now, but it does make companies like Skyrora, RFA, and others over there a little bit more viable. And it's also a reason why ABL is trying to do business in Shetland. In other words, trying to do business in a place where they are more likely to get customers than trying to compete in this increasingly crowded American market. So what's going to happen to these other companies? What about Relativity Space? Why did they launch the Terran 1 in the first place? Well, in my opinion, it was simply to demonstrate their capability to send the world's first Methalox-powered rocket into space. Sure, not into orbit, but it got past the Kármán line, and that was accomplishment enough, and why they were so overjoyed and celebrating on the Relativity Space sidelines. But wait a minute, let's keep things real here for a moment. I mean, Relativity Space and Terran 1 didn't really accomplish a whole lot more than Starship did. Yeah, it got a little bit more altitude, but with a rocket that they're not even going to be using in the future, whereas Starship most definitely has a future. So what purpose did this possibly serve, and why were they so excited? Well, it simply demonstrated Relativity Space's capability of getting into space in the first place, their capability to build a rocket and to get past the Kármán line, and that was enough to secure over $1 billion worth of future business for this. Now, the Terran R, of course, cannot hold a candle to Starship, so why has it secured over $1 billion worth of business? Well, because since SpaceX essentially became the only game in town for low Earth orbit, they have been increasing their prices. That's what happens when you secure a monopoly. So various companies that are looking to get a better deal to low Earth orbit are looking for other alternatives, and Terran R seems like a very good possibility. Its current capabilities, at least in theory, are 23.5 metric tons to low Earth orbit or 33.5 metric tons in expendable mode. That's not really all that different from Falcon 9, and its GTO capabilities of 5.5 metric tons, that's actually exactly the same as Falcon 9, at least in reusable mode. That's something we need to keep in mind. All of the statistics that SpaceX puts on their websites for their various rockets reflects an expendable payload and not reusability. And by the way, Relativity Space is now spelling out their justifications, their school of thought, shall we say, as to why they started out with Terran 1. Quote, "The technologies created throughout the Terran 1 program were intentionally envisioned to build direct experience relevant to Terran R. Now it will enable our team to capitalize on a significant experience base while executing Terran R. Ultimately, Terran 1's flight delivered highly valuable data to inform and anchor our models and simulations. The following is directly applicable to both the ascent and entry reusability on Terran R based on the design, analysis, development, qualification, certification, and flight test approaches from Terran 1. So essentially, Terran 1 allowed Relativity Space to master their 3D printing processes and also all of their in-house technologies, which are going to be very important for Terran R, and also to master their Methalox propulsion systems. Obviously, Terran R is going to use much bigger engines, but utilizing a lot of the same principles. Like Falcon 9, Terran R is a two-stage rocket, with the primary stage being reused as many as 20 times. There are a couple of differences, however. First of all, Terran R is a Methalox-powered Falcon 9, which gives it the theoretical capability of carrying larger payloads and delivering more thrust than the Merlin engines are going to be able to deliver in the future. Once again, however, this is theoretical. The one thing that gives Terran R a big advantage is its fairing size. Terran R has a 5-meter fairing, a little bit wider than Falcon 9, but it's an important difference. But more importantly, it's a much longer and more spacious fairing than Falcon 9 or Falcon Heavy has at their disposal. This is something that gives both Vulcan Centaur an advantage and also theoretically Terran R over the Falcon series, at least until Falcon 9 comes up with an extended fairing, although that's probably only going to be used on Falcon Heavy if and when it finally comes out. Elon Musk doesn't seem to be in a big hurry to build an extended fairing for the Falcon series of rockets. That being the case, then, both Terran R and Vulcan Centaur are going to have a volume advantage over Falcon 9. And this is sort of a misleading diagram, by the way. Vulcan Centaur has an extended fairing that's bigger than any of these rockets. So what Relativity Space is doing essentially is doing a one-up on SpaceX with Falcon 9. But how is this going to be able to compete with Starship, given the fact that both rockets are probably going to be operational at roughly the same time? We're going to get to that right after we talk about SpaceX's other major competitor, a company that actually is launching rockets into orbit on a regular basis, and that, of course, is Rocket Lab. This, by the way, is not a Falcon 9 re-entering the atmosphere, nor is it a rocket that's firing its boosters or anything like that. What you're actually watching is the fiery re-entry of an Electron booster, and no, it's not using its engines at all. All of that fire is coming from re-entry, and one would think that this booster is not going to be able to be used for anything at all in the future, but that is not the case. What you're about to see now is a recovered Rutherford engine firing once again after being fished out of the water. This is something that was a serious problem for shuttle technology every time they tried to reuse a solid rocket booster, an RS-25 engine. It had to go through a tremendous amount of work, lots of money, lots of time being invested in this technology just to reuse it. This doesn't seem to be the case with Rocket Lab's Rutherford. Therefore, they are able to reuse the first stage on the Electron without any sort of landing platform, no landing barges, just a parachute and water recovery. Now, this may not be the case for their future rockets, but that's not really what they have in mind. The Neutron is an even smaller competitor for Falcon 9. It has a smaller fairing. It has a smaller payload. So how the hell is something like this supposed to stand up to Starship? When we're talking about launches for the next 10 years, there's a very important factor that we need to keep in mind. The heaviest payload that SpaceX has ever launched into space was 17.4 tons. And by the way, this happened just a couple of months ago. Let me say that again. The heaviest payload that SpaceX has ever launched is 17.4 tons. And by the way, that was a Starlink launch, a SpaceX cargo, indicating that the current market really doesn't have a need for massive payloads. They're not even maxing out Falcon 9's theoretical capabilities. Falcon Heavy is capable of carrying even more into low Earth orbit, but it isn't doing that. It's carrying those payloads out to geosynchronous orbit and not even close to 17 tons, only about 8 or 9 tons out to geosynchronous orbit. The fact of the matter is, the current market simply doesn't have a need for 100 metric tons, and it gets more complicated than that. The Neutron is going to be manufactured out of 3D printed carbon composites. Now, this theoretically is a very expensive process. However, Peter Beck claims that Rocket Lab has gotten so good at manufacturing carbon composites that they can churn that stuff out at a rate of meters per minute instead of millimeters per minute. I don't know if he's telling the truth here, but I don't know. There's something about the guy's New Zealand accent that seems very authoritative, so I believe him at least at the moment. But Neutron's capabilities are tiny compared to Starship, only 13 metric tons if you're using it in a reusable capacity and landing the booster downrange. However, once again, it may not need to carry any more cargoes than that, especially if you're only charging $50 million per launch. $10 million less than a bare bones Falcon 9 launch. And by the way, as you can see here, Peter Beck is throwing a little bit of shade at Starship by showing just how bad stainless steel is for building a rocket of the 2050s. Now, once again, I'm not saying he's right, only that he makes an interesting point. Carbon composites are both incredibly strong and incredibly lightweight. This, in theory, should allow the Neutron to carry even heavier payloads, but why doesn't it? Well, because it's Rocket Lab's philosophy to use Methalox engines that don't overtax the capabilities of the engine. In other words, not run it up to maximum pressure. Neutron's tapering design is intended to make maximum use out of the atmosphere in reducing neutron speed when it's returning to Earth. In other words, it's not going to have to use its engines as much in order to execute a landing, and it's not going to have to use its engines as much to achieve orbit. What this means is, at least in theory, it's going to be able to reuse those engines and reuse that first stage a lot more easily, a lot longer, and a lot less expensively than any of its competitors. Less expensive than the Raptor 2s, which are going to have to be used to maximum capacity to haul such a tremendously heavy rocket and tremendously heavy payloads into orbit, and to achieve superior reusability to ULA and relativity space as well. The whole philosophy, and this is kind of unique by the way, and I like it, is to use the engines less, to put them through less stress, less abuse, less punishment, and you'll get better reusability out of both the engines and the booster. If Rocket Lab can indeed achieve this, it means that they're going to be able to launch for a much lower price, even if they can only haul 13 tons at a time. So what does this mean? How do these rockets, which carry so much less than Starship, compete with Starship in the future? Well, as we have seen recently, Starship is going to require a lot in order to get into orbit. A very resilient launch facility, a very large exclusion zone, and even then, we can't be certain if this incredibly powerful rocket is going to be able to achieve the kind of launch cadence that Elon has been talking about for all of these years. It may just be a little too difficult to make something this enormous work this well, this frequently. And if that is indeed the case, smaller rockets like Neutron, Terran R, and indeed even Falcon 9 are going to be extremely viable competitors for the next 10 years. I think that this is probably a good business model. Now, after those 10 years, Starship will really start to dominate. I feel that the market will probably catch up to Starship's enormous payload capacity. We're going to be building even bigger space stations in orbit, bigger than Orbital Reef that only really requires 5-meter fairing rockets. We're going to be hauling larger numbers of people into orbit, whereas right now, the Dragon, the Starliner, the Dream Chaser, all of these only require 5-meter fairings, which the Neutron and Terran R are capable of providing. But once all of these things move on to the next level, once the market catches up with Starship's payload capabilities, everything is going to change. And in the meantime, Starship is going to be able to deploy huge numbers of version 2 Starlink satellites. It's going to be carrying our astronauts to the surface of the moon. It's going to be carrying out a wide variety of incredibly important tasks for the space industry. I just don't think it's going to completely dominate everybody. And I think that little competitors like Relativity Space, and especially Rocket Lab, that already has a very good established history of reliability in carrying payloads to space all the time and doing it very well, well, I think these little competitors are going to prove themselves worthwhile adversaries. Thank you very much for watching. Please like, please subscribe, and as always, stay angry about space.